All right, so we're doing the two sample today. This one is the two independent sample, and the last one is going to be the paired sample. And then chapter 11 will be done already, which is crazy. We are so close, you guys, to being done. I know. No, but only because I wanted to split chapter 12 into two little pieces. So I'm gonna do like a half test before spring break and a half test after because I don't want you to have to retain everything over spring break. What do you think? Okay, it's better, right? Okay, so we're gonna have plenty of time to review for the AP test and all of that. I just didn't want you to have to remember a ton of stuff for one test. Anyway, okay, so for the state, we have a null hypothesis. We have an alternative hypothesis. We have one mean, and we have another mean, and we have alpha. So the two sample ones, I know they're annoying because there's double the samples, I guess. But anyway, okay. The good news is the null hypothesis is always the same. Mu1 minus mu2 equals 0. It says there's no difference between the two means. You don't even have to think about it. It's always that. Okay, now the alternative hypothesis is either going to be less than, greater than, or not equal to 0. So just like before, you're going to pick one of these three, depending on the wording. Okay, mu1 is going to be the true mean something of whatever the first thing is. Mu2 is going to be the true mean something of whatever the second thing is. And alpha is given to you in the problem, and if it's not given to you, what do you use? 0.05. Yes.
Question about me that is like two-sided. What else in the test is like two-sided or one-sided regarding significant?
So two-sided means not equal to, and one-sided means less than or greater than. So it's from the wording unless they tell you specifically. Are you sure that's okay?
No.
Okay. 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 Random. Is any of this news to you? No. Okay. Okay, so this is annoying. If both of them are less than 30, that means you have to do two graphs. Um, I'm really sorry to tell you that the example today, they're both less than 30.
Oh.
Yeah, but I'm just so lazy. I just usually do the box plot from the calculator. Okay. Any questions about the state or the plan? You guys, none of this is really anything new. Okay. Okay. So statistic minus parameter over standard error. Statistic is the same thing as this. It's just that you change it from population to sample. So it's just the X bars and then minus the parameter. The parameter is 0 because that's what we wrote right here. And then there's your standard error formula for two samples. Let's locate this on the yellow sheet. If I was taking the test, where could I find these things? Okay, so there's your standard error. And then right here, standardized test statistic, which is going to be T in this case, statistic minus parameter over standard error. And notice right here, it even tells you what the statistic is. Okay, and then you guys okay? Yes. Hey, make sure to label degrees of freedom in your p-value statement. And also, degrees of freedom is n minus 1 for the smaller sample size. Has to be for the smaller one so that you're conservative. You can't say that you took a bigger sample than you did. Okay. I just did that backwards. Okay, do you guys have any questions about anything I wrote? Does it make sense about degrees of freedom is n minus one of the smaller sample size? And then we've been writing this for some time, so. Did you guys see how I like split the arms up? Yeah. Okay, okay. I'll check it one more time before I print them, but I think this works pretty good. Okay, make sure that you've got a calculator, please. I know, I'm sorry, I won't do it again. I'm so sorry. I promise it will not happen again. He's awfully cute though. It's a planet playing a guitar. Oh wait, it's a winking planet playing a guitar. Also, my squishmallow from today's calendar, I've decided has to go on the purchase list. He's a chameleon. Look how cute he is. His little eyeballs. Anyway, sorry. Okay. Alrighty. Students performed an experiment to see if plants grow more when exposed to classical or metal music. Did you guys do this like as a science fair project ever? Like play music for plants? It's kind of a popular one. 10 bean seeds were selected and planted, and half were randomly assigned to be exposed to metal music each night, and the remaining to classical. The amount of growth in millimeters was recorded after 2 weeks. Here is the data. Okay, so we have metal, 5 plants, classical, 5 plants. Do the data give convincing evidence at the alpha equals 0.05 level of a difference in the mean growth of plants like these that are exposed to classical or metal music? Okay, state. We need a null hypothesis. We need an alternative hypothesis. We need to decide which one we want to be 1 and which one we want to be 2. And I just like to state alpha for the record. Okay, for all of these, the null hypothesis, this is the same thing. mu1 minus mu2 equals 0. No choice, same thing every time. Okay, now from the wording of this problem, is this one less than, greater than, or not equal to? Okay, the answer is not equal to, and the way you can tell is because there's the word difference in the problem. So if you look here, this word is what tells you that you have a not equal to. It doesn't say that metal is greater than classical. It doesn't say classical is greater than metal. It just says a difference. mu1 equals the true mean Uh, should we do metal is the first one? Okay. I'm sort of paraphrasing here. You should technically say after listening to or being exposed to, but it's fine. Yeah. Okay. Random. Is it random? Random assignment. Nice. Okay. What does that mean for us? Right. I'm going to put does not apply because it's notes, but you can just skip it. Oh, I forgot to put 5. Okay. So we're going to practice this calculator stuff now. What I want you guys to do is to create 2 box plots. Now, you can create box plots with one axis. So that's what I'm going to do. I'm just going to make 2 stacked box plots. So let's go to L1 and L2. We all need to practice this. I'm going to put the metal um, data into L1 and the classical data into L2. Is anyone else concerned about the 5th plant in the metal group? It seems to be, yeah. Okay, now I'm gonna give you a hint in a minute, but let's do the stat plot first. So, what is the lowest number? 3, right? And what's the highest number in all these? 124. Okay, so I suggest that we start at 0 and go by tens for our axis. And make sure to leave some room because we're going to do 2 dot plot or 2 box plots above this axis. So Mhm. um, I'm going to put 2 separate graphs, but I'm going to make only one axis. Okay, so let's get the axis all set up first before we go to the calculator. Okay, so, oh no, I deleted one.
Uh-oh.
87? Okay. Anyway, all right. So now I'm gonna go second y equals, and you want to make sure this is probably still on from yesterday. If it's not, go into the settings, make sure it's set up like this. And if you're fancy, you could do both at the same time. I'm just gonna do one at a time. So the settings should look like this, and then hit zoom 9. And then the trace button. Okay, so minimum is 3. First quartile's 12.5. Median's 36. Third quartile's 65. And max is 73. Okay, and then connect. Connect. I don't think plants like metal music. Okay, now next time you guys go to stat plot, so go second y equals, hit enter and change your X list to L2. And to do that, hit second 2. So the second button, 2. And then zoom 9 again, and you'll get the other one. $19, 48.5. Are you guys okay? You might wonder to yourself, gosh, this one looks pretty skewed. I wonder if it's okay. The book says yes, so we move on. I wonder myself. I was like, it looks pretty bad. I mean, on an FRQ, it's never in question. You always just write no extreme skew or outliers and keep going. Now, if it's on an MCQ, you have to be more picky. And the MCQ would only be like, is this what's wrong with this? Blah, blah, blah. Like, or does this meet the condition or whatever? Okay. Now we're going to get these values from the calculator also. Make sure that your box plots are situated. And then, because it's a 2 sample, instead of doing 1 variable stats, you're going to do 2 variable stats. So go stat, calc, don't do one variable stats, do two variable stats. And it'll ask you, what do you want for your lists? So my first list, the mean is 38.2. And the standard deviation is 27.71. And then for my second list, the mean is 85.8. And my standard deviation is 42.49. You see how you can get all four of those numbers with one thing on the calculator? Because we're lazy. Okay, so now x bar 1 minus x bar 2. Does my standard error make sense? Where I plug the things in? Okay, I just typed it in one swoop, so 27.71 squared over 5 plus 42.49 squared over 5. 22.69. It's probably the biggest standard error we've ever had. It's very spread out. Okay. T equals statistic minus parameter over standard error. Degrees of freedom is 4. Oh, I just typed over top of that. Oh no, that's so sad. We reject or fail to reject. Fail, sadly. Can't bust out of skipping with my tuxedo on, rain coming down, the confetti and excitement. Now I forgot what the question was asking. Why am I not surprised that playing music didn't really affect the plants? Okay, you guys have 15 minutes left. I have a special challenge for you. Try not to look back into your notes and try to remember the sentence for interpreting the p-value for the situation. Work together, try to talk it out. Remember that test day you came in all saying it. Assuming.
Assuming the null hypothesis.
Okay, but then you got, what is the null hypothesis in this problem? You got this.
Having two values of, of something more or less. After many.
AP exam, you just have to do your best. We're gonna practice a lot before.
Yeah, 3 coming through. Perhaps the
So-
2.
Seems that the null hypothesis. I knew myself.
No way you're. Say out loud. Then go back and look.
So I just felt I was saying that.
Okay, I got you started. Because you're right. You're saying null hypothesis is true. You can't just write u1 minus u2 equals 0. That doesn't give enough information for context. Okay, what comes next? What comes next? Okay, there is a. Ooh, nice, but what? Ah, ha. Great job. Of what? Nice, yes. Yes, okay, but what's the something? You've got it. That's the p-value there, honey.
A random sample
No,
of obtaining a similar sample.
Okay.
I'm obtaining a probability.
Okay,
Right there, bro.
it's about the sample. It's about the sample. Usually it would say sample mean, but this one, we're interested in the difference of sample means. Or more extreme. Nice. I heard it. Crap. I forgot the just by chance part. Just. Okay, now, we can't say random samples. That was rough, but okay, good to do. Very good to do. Bring that back up.
Yeah.
Okay,